Hello, Kader.
Morning, Kader. Morning, everyone.
Hi, Nikki.
Hi, Kader.
Hey, Shaktivel, how are you?
Yeah, I'm doing good, Kader.
Awesome.
Hello, Kader.
Yes.
Audible?
Yes.
Yes.
Hello,
Thank you.
Kader. Hello, Parthiban.
Hey, Yogesh. Good.
Let's see. Okay.
Hey, Carter. Sorry took me a while to get my audio set up, but I'm all set up, I believe.
Yeah, it's last minute. These things happens for sure. Just checking something here to make sure. Good. What is Zoom? Okay. Make Parthiban. Kendall, we have to make Parthiban also as a host. Mark, from your end, who is presenting, sharing the screen and presenting, you or Govind?
I'll be presenting.
You'll be presenting, right? So Kendall, if you can make Mark also as the presenter, Parthiban and Mark as a presenter, I would really appreciate it.
Yep, just did. They should be good now.
Yeah, that's another note. Perfect.
Yeah, let's give it a minute more. We normally cross 40 plus before we start. I think we are around 38 if I'm not wrong now. Just checking. Okay. The slide is moving.
Yes.
Perfect. Let's give it a minute and then we will start. Is Govind also here with us? Sorry, I can't see the names because I'm sharing the screen. So Mark, Govind is also with us?
Yeah, he should be. Just waiting to see if he can turn on his audio.
Sure. And what about Yogesh?
Yes, Kader, I'm here.
Okay. Perfect. Let's get started for today. All right. Welcome everyone for Magma 5G, Everything You Need to Know meeting. Last month, we got to skip it because of some personal reasons. We couldn't make it, but we are back, happy to be this month. My name is Kader. I'll be the host of this meeting today. And as you all know, this meeting happens once in every month, second week of Friday. So looking forward to you all joining next month meeting as well. So today's agenda is pretty much jam-packed. I'll start with a little bit on enabling adoption for Magma for 5G, some of the activities that we have been doing from the community and also from the Wavelabs point of view. Followed by, we will have Magma features dev, test, and ops update, where we are with all the with respect to the features that we have been implementing in the community. Then most interesting thing is there's a lot of different products are getting integrated now with Magma for 5G. So we have integrated a couple of radios, and we are talking to a few additional radio vendors to integrate. And in addition, not only the radios, but also we started integrating some of the other tools like BSS, orchestration, lifecycle management with some companies like Arna. And today what we are going to present is one such a nimble company called MyCloud BSS that has been integrated with Magma. And in fact, there are some deployments that we have done my cloud BSS in some of our customers as well. So happy to show the integration of that with 5G today. And then Mark and Govind will take over the floor and they'll be presenting about the ARM ecosystem for 5G Magma and all the good contribution that ARM has been doing in the community. Excited to hear from them. And finally, we'll close the session. So moving on. So I know that most of you, I see repeated attendees, and some I also see new attendees. For those who are new attendees, we know Magma is, 5G is a great opportunity for all of us. And so Magma is a great opportunity for all of us. The meeting that we do every month with a intention of three key things, right? The first thing is we wanted to really update all the development activities that's happening in and around Magma. And the second one, we update what kind of a collaboration that we have outside of Magma community, such as Linux Foundation Networking, Blueprint and other open source communities. And the third key objective is to show the demos, integrations, and support whatever that's been ongoing right now with respect to 5G activities in Magma. So end of the day, why we do this, we wanted to, together as a team, enable the engagement, collaboration, and adoption of Magma for 5G. That's the end goal. So now, like I mentioned, Magma is a great opportunity for all of us, right? 5G is a great opportunity for all of us. Considering Magma today supports broadband, there's a number of industries that we can address in Industry 4.0 ecosystem when it comes to the private wireless, in addition to the fixed wireless access use cases. But what is important to understand here is that most of the, it's not about just having a product, right? It's about having services and solutions, end-to-end solutions around it. So what's important for the community, to do together is that we as a community have to build the expertise, not only within Magma ecosystem, but also that surrounds the Magma that makes up the end-to-end network. So in nutshell, at least Wave Labs, we call it as a 2I strategy. And the first I, we call it as an expertise. We try to build expertise within Wave Labs and also help building the expertise of Magma outside of Wave Labs through a lot of activities that we do. One such activity that we have been doing is called as Decoding 5G, where we are skilling up and innovation up not only the Magma, but also the complete end-to-end 5G ecosystem and hands-on Magma exercises and so on. 5 sessions has been completed. It happens bi-weekly. There's a post in the Slack, and I'll also make a fresh post later this week or tomorrow, next week. You guys can join that session if you wanted to learn more about 5G as a whole and Magma hands-on. And we also contribute in a number of other areas to build test plans. So end of the day, building an expertise within and around the community is very critical for the adoption of Magma. And the first I strategy, we call it as an expertise. And the second I strategy, we call it as an ecosystem. It's not only good enough to just know Magma, but also see how Magma can fit into the end-to-end ecosystem like LF and Blueprint. So we have been contributing a number of activities in LF and Blueprint, not only with Magma, and integrating Magma with all the different components around it. And we also have proposed to set up an innovation and research lab within Wave Labs. Some of the work is already ongoing with some of the both the closed source and the open source partners to build this ecosystem. So again, bottom line, if you wanted to really enable the adoption of Magma, building an expertise and ecosystem is key. And that's what we strive to do day in and day out from the community as well as from the Wave Labs point of view. Last but not least, if you need any support with respect to Magma for 5G, please do feel free to reach out to us in the Slack channel, Wave Labs 5G support. We'll be happy to respond and get you onboarded. Just to make the life easy, we also have an orchestrator deployed in the Amazon for free for the community members. So you don't have to struggle there. Just install just a gateway and connect to our orchestrator and do some testing right away. So looking forward to help you guys to start adopting Magma for 5G. So that brings to my quick 5 minutes presentation in today's agenda. Now I would like to hand over it to Yokesh and Parthiban to give us a good, quick update on what's happening on the development, test, and ops front. We released 5G 1.7, alpha a month ago. Now we are working on releasing release 1.8 GA. It's coming up in a month or so. So I'm excited to hear from Yokesh and Parthiban where we are and what kind of features that we are planning to implement and so on. So with that, I'd like to hand the floor to Yokesh. Yokesh?
Yes, yes, Kader. Thank you very much, Kader. So hi everyone. So I think in the month of March we released our Magma 5G feature set. It contains all the basic procedures like registration, authentication, session establishment, paging, service request. So with 1.7 in place, we can enable the 5G on the and connect to the GNB and provide the services. It's alpha because it is the first time it is there in Magma. But with our validation ongoing, we are making it more stable. And the next target is to have it as 1.8 as a GA release. Okay, so these are some of the features which we are planning for 1.8 GA, starting with 5G QoS. Some basic QoS is already there in 1.7 release, but the target for 1.8 to have is comprehensive test cases for QoS. Again, then we have a feature parity with 4G, that's called a stateless feature. Where the AMF or Magma MME can go down and come up, and there will be no effect to the services. And then we have network initiated session modification, where the QoS can be modified using the PCF feature. Then we have SUSE extension. Basically, it will encrypt the IMSI or the subscriber identity as specified by the 3GPP spec. So even the initial registration also is encrypted. Then we have already provided the support for IPv6 and IPv4 v6. So that is also, and all the basic registration and traffic testing is through for 1.8. GTP extension header with QFI. So this feature we have introduced in, or rather we have modified the Open vSwitch, and we have provided the QFI support in Open vSwitch, and that being a kernel component. Now we will be filtering the traffic based on QFI and will marking the packets which are ongoing using the QFI. Then coming back to orchestration internal endpoints, basically there was some security related stuff which has been reported, and there has been a suggestion to use specific endpoints. So the 15 line item is for that. And then the last item for SCTP full and partial reset. So basically, this is to take care of all the shaky scenarios where your GNB is restarting or some cleanup is required. All the disruptive kind of handling is there as part of SCTP reset. Yeah.
Thank you.
In this, we are going to specifically cover about SUSE extension and IPv4 v6 support. The one which is there highlighted in blue, we have already covered in our previous sessions. The ones 14, 15, 16, maybe we'll cover in the upcoming sessions.
Thank you, Yokesh. For those who wants to know a little bit more detailed than high-level explanation what Yokesh did for feature 9, 10, and 11, you can always go back and refer the previous video in the YouTube. Over to you, Yokesh. Go ahead.
Yeah. So this is just to give an overview of how we have done the SUSE support, like how we are concealing the SUSE, the SUPI inside. So this way we will make sure that the IMSI or the SUPI which is there in the packet will be encrypted, and it will be difficult to derive the registration procedure by any sniffer or IMSI catcher. We have implemented based on IES protocol as per the 3GPP spec, and we support both profile A and profile B. That's the different encryption algorithm as specified by 3GPP. On right hand side, we just showing the highlight in the orange color how the encryption algorithm works. Basically, if you say protection algorithm A or B, we will have a public key which is generated based on the private public key pair, and the protection scheme output. This will contain the MSIN in the encrypted format. The MCC-MNC is still not encrypted, but the user-specific MSIN information will be encrypted based on the public key and the scheme or the algorithm used for encryption. Yeah. So this is little hazy, but just wanted to show that this is how on the top we show how these profiles are getting configured. Basically, we have to have a private public combination, and there is a indexing, like you can have like 5 or 6 such combinations, and then we have to check the scheme type, like is it profile A based algorithm or profile B. Based on that, the decryption or the received packet will be decrypted to get the MSIN. The same has to be configured on the UE side. And as you can see in the Wireshark capture, the initial registration packet, the first one which is highlighted in blue color, the scheme output will be encrypted. So basically, we will not be able to see which is the MSIN. We'll just have a big encrypted data with a lot of hidden information. And once this is received, we will decrypt it, and the rest of the session will go through. So this shows that we received such a packet, and then we are able to establish the session, including the PDU session establishment. Yeah, this is for the IPv4 v6 dual support. Basically, we are just capturing the control plane part of it. The data plane will be the usual IPv6 traffic on the GTP. Here, the v4 v6 combination is meant only for UE. GNB is not part of it. GNB is still on v4. So what we'll do is, if UE is requesting us for a v6 or a v4 v6 session, we are going to honor it. The relevant IP addresses will be assigned to the UE. Basically, here in this case, the link local, and then with router solicitation advertisement, the UE will be able to make a internet call or make a data call to the internet. This is just a brief summary. Yeah, of course, as Kader mentioned, if there is any specific feedback or if there are any questions, please reach out to us.
Yeah, thank you.
Over to you, Artiman.
You can also post it into the chat channel. So we'll be happy to help you. And there are a few additional features that are getting implemented, will become part of release 1.8. In our next monthly meeting, we'll talk about the detailed implementation, as Yogesh talked about a couple of features in this session. Let's get some update from Parthiban for test and ops.
Yeah, thank you, Yogesh. Thanks, Kader. Yeah, I think Yogesh has given a high-level view of what's been available in the previous 1.7 release, and he has also mentioned the reason why it's called alpha, because it was Magma is having the 5G core added into the converged core as a first time. And now that we are going to release targeted 1.8 with additional features, the things are very stable now in the integration testing part of it. So the targeted 1.8 release, the testing is going stable, and we are running daily regressions as well. You could see that there is a CI dashboard, which is being put on the right side over here. This is the health line, which is running for the Magma right now. And you could see that there are a couple of blank and yellow dots. It is because of some unexpected power shutdowns over there in the lab, and that caused some queue to be failing over there. That was the reason behind it. It's all completely stable over there. You could see the greens, and all the coming days are also green over there. And on the scale test front, we are making sure that the numbers, whatever been honored in 1.7, is being already kept intact, and we continue to test with the same scale, and we are making sure it's also going to be same with 1.8 release as well. So the numbers are very well readable. The 200 UEs with four sessions, 4 PDU sessions per your UE, and 4 policies per UE, and 400 Mbps throughput. And with the 5 attach rates per second are being honored right now, and 12 GNBs are able to make a connection at the same time. And this has been repeatedly tested in the NAT mode enabled, and it has been still honored over there. 1.8 release will also see the same thing. And real equipment testing, we have done the real equipment testing with the Bisel GNB in the TIP lab, and we have released it, and we are continuing to do that. And we are also having plan to release with a few more radios in pipeline. And I could share more. I'm waiting to share more into the community once it's all confirmed. We are trying to secure them out.
Thank you, Parthiban.
Thanks, Kader.
Sure. Thank you, Parthiban. There's one quick small mistake that I noticed. After plus, it should have been a 1.8 release features. So the idea here is we are ensuring the 1.7 plus 1.8 features together. All the regressions are stable. New features are added. New regression tests are added. New feature tests are added. Performance integration, unit testing, and real equipment testing from all perspective. We are able to do it, so we can release a good GA release with all these features as MVP. Thanks again, Parthiban, for your great support on this. Now let's move on to a quick demo with MyCloud BSS. Let me say a couple of words here. MyCloud BSS is a business support system, as you know, in a telecom network, right? When you're deploying it for FWA or any CSPs, the subscribers, they come in and they buy the SIM card from franchise or directly to all the way to managing the SIM management, to billing them, sending the bills and getting paid. It's all fall under the scope of business support systems. And MyCloud BSS basically is a company which is a nimble player who has built a very cost-effective BSS system, future-ready charging and revenue platform with number of features, as you can see here. From the architecture point of view, it just sits next to the Magma orchestrator and connects to it, and it does its job, right? So pretty much that's what it is. And Parthiban would be showing the demo on this quickly. Moving on to the next slide, Parthiban, you want to take over from this slide, please?
Yeah, thank you, Kader. Thanks for this opportunity to present. I'm really excited to show this to the community, a new integration into the Magma 5G actually. So this is one of the end-to-end FWA production network shown here as an example here. You could see here we are able to put the MyCloud BSS integrated with Magma, and it's able to provide the billing solutions for this and end-to-end FWA, which is in the production right now. And we have used our ecosystem, the partner ecosystem over here to achieve this one. And this is visible over here, the OE time SIM management, which is the SIM software and the Bisel radios and my Microtech for their transport and stuffs like that. So we are very happy to say that the Wavelabs distro now has the ready to use MyCloud BSS integrated solution available. And we could be able to even give a demo and also the POCs for community members to try it out when you are interested about it. Yeah, we can quickly jump into the demo. I could share the screen and
yeah, that would be good. If you can share the screen, or if you want me to share it, I can do that.
I can do that.
Sure, please go ahead.
Okay, hope my screen is visible. Yeah, Kader, is my screen visible over there?
Yes.
You're good.
Yeah, thank you all. Yeah, we have done a simple screen recording over here just to avoid the network glitches, whatever we are facing over here, right? So that's the reason of having a recorded demo over here. So I'm just playing it around. So what we have done is you could see here, we are just starting with our Magma orchestrator page, where we would be able to show you here that the list of IMCs, list of subscribers, which are added into the Magma orchestrator already. From there, I'm just jumping into the MyCloud BSS administration page, where I go inside this admin page. The MyCloud BSS has an administration page, which has a lot of features as was discussed in the slide. One of them is the SIM management, where we could go ahead and add a new SIM card. And you can see here, this is the list of SIMs available here. I'm just clicking on to add a new SIM. I'm going to add an IMC, which I'm taking out all the IMC with the SIM authentication vectors, details and stuffs like that, which will be the opt key, the auth key and OPC values, and fill in MS ID and values over here. Yeah, and fill it out, all the SIM types and what's the millage and who is going to be the partner for this, meaning he's the ISP over there. You can see that the SIM card got added over here. The new subscriber is added over here. What I'm doing here is now I'm going to assign this one to one of the franchise of this ISP who will take over from here, the SIM card, for making this into the sale chain. So it goes from here. From a franchisee, it actually goes down to a dealer. So this is how the cycle works. So we could see here the MyCloud BSS has independent applications on the cloud where you could be able to get into each of them. Now it is inside the franchisee login where we could be able to see that this SIM card got assigned to this franchisee, and this franchisee can assign this in turn back into one of the dealer who is going to make this sale of the SIM card. Okay, so now from the franchisee, I could go into the dealer website. The reason is this dealer will again give it back to the retailer. The retailer will be someone like in your nearby convenience store or a medical store person who is actually making the sale to the end users over there. So he takes up this and he is again assigning it back to one of the retailer out of this dealers. Okay, now you can see this quickly. You can do this, and this BSS SaaS application has a lot of features, including the SIM management, SIM tracking, and the sales data and the stock data and everything over there. So once we get into the retailer part of it, you could see that this is the retailer SaaS app where you could be able to see what's going on in the SIM card. You could see here. Now you could be able to go to the SIM card and you can, now I switch on from here into actually one of the point of sales app, which is actually an Android app. Okay, which you could see that most of the retailers in the convenience stores are over there, uses and point of sales app over there. They are very convenient using a mobile app rather than using it over a web pages or a SaaS application. So you can see here, this IMSI is available here. This SIM card is available. Particularly this SIM is ready for a sales now. So now he could make a sale. Now he will take out this and he is going to fill out this KYC form for it. An end user needs to give out an KYC, know your customer. So this is an demo purpose. So we are just taking out a scan of a picture over here in the place of a KYC. You can see which will be like proof of identity and proof of address. Each of these items are scanned and video pictures are taken out and it gets digitally added into the retailer app, which will verify that this is a valid end user who is going to purchase the SIM card over here. So you could fill all, once you get all this proof of address and proof of identity, yeah, those are been getting captured now. See it on the screen. Yes. Yeah, then there is a application form which has to be filled in out, which will give details about the end user, all the address details and the KYC details and the all of those alternate mobile numbers. All of these details are getting filled out over there into this form, which the retailer uses it to get the end user. Yeah. And once you fill in this details over here, yeah, you could be able to choose it's a postpaid or prepaid, and you can choose the data plan as well. Now we are choosing an 1 GB data plan over here for this particular subscriber. He is making a cash payment over here. Then that cash payment is being taken out and you are able to assign this SIM card actually to one of the end user. Yeah, there was a simple mistake, added an alphabet into the mobile number, alternate mobile number. That's why it's not allowing to order that SIM. Now it's been successfully done. You could see that. Yeah. Now, once this is done, now we could even MyCloud BSS provides an end user application as well, the SaaS app as well. So you could get into this one. The last 6 digits of the IMSI becomes the end user's username, and there is a default password given out to the alternate mobile number, which will be used by end user. Now you can see that 1 GB data is already credited into it. I'm back into the Magma's orchestrator page where the subscribers are listed down. I'm refreshing it. You could see that the 06, the new subscriber is added here, and the current usage is 0 bytes over here. Now the interesting stuff is I'm getting into the Magma AGW. I'm going to log into it. I'm into the terminal. You can see here I'm into the showing up the SCTP ports, which are listening for the NGAP messages from the UE. Now I made a connection of that particular user whom the SIM card got assigned. Yeah. Now what I'm going to do is I'm going to make some data traffic over here. So I'm just listing on the OVS table, and I'm using one of the utility called Scapy, which will generate some traffic to this particular subscriber. So I'm going to just generate some traffic using this utility called Scapy, which will generate traffic from source IP to the destination IP. I'm just modifying it into that utility. I'm just saving it out, and I'm going to pump now the traffic from here. Yeah, so you could see here the traffic gets increased. You can see here, you can see in the end user app as well, the consumption is been getting updated over here for the end user. So this shows the end-to-end availability of this iCloud BSS solution integrated with the Magma 5G. Yeah, this ends this demo. Yeah.
Thank you, Parthiban.
Kadar, back to you, Kadar.
Yeah, sure. Thank you, Parthiban. It was a good demo. Those who wants to try out myCloud BSS into your implementation and distro, reach out to us. I'm very pleased to say that we have partnered with this Nimble player as an exclusive reseller as well, right? So we'll be happy to help if you wanted to explore more. Reach out to us. Moving on, we are on time. Let's see. Our next agenda is. I would like to, I'm pleased and honored and like to invite Mark on the floor to present about ARM ecosystem for 5G Magma and all the good work that they have been doing from multiple directions, right? So Mark, floor is all yours. Good luck.
Thank you, Carter. And I'll be just sharing my screen here. Let me know when everything comes up. Should be able to see it now.
Yep, we can see.
Perfect.
Perfect.
All right. So first of all, thanks, Carter, for giving us an opportunity to talk about the advancements of ARM in the ecosystem in 5G infrastructure. So my name is Mark Meunier, and I lead software ecosystem development for Edge in the infrastructure line of business at ARM. And I'm also a Magma Core Foundation board member. Today, I'll be co-presenting with my colleague Govind.
Hi everyone, I'm Govind. I'm an engineer in ARM. I'm a TSC member in Magma Core Foundation.
Thanks, Govind. So what we've prepared for today is a broad set of topics that center around the work that ARM and ARM's partners are doing to help the developer community in network infrastructure, which includes 5G. So we'll start by looking at ARM's collaboration and programs in general, right? So we're going to just start quite broad here. When we look at the 5G supply chain, we understand that it's constantly evolving. And ARM is collaborating across the industry, building a strong ecosystem to meet the various technology needs, but also at the various links to facilitate deployment of these technologies. So 5G, as you know, right, brings a new set of use cases, which is significantly more complex. And we have a new set of requirements, such as being cloud native. So you look at where we are today with networking, and there's two things hitting us: new technology with 5G and this desire to bring cloud native development to this environment. So by generating a wider base of collaboration, ARM's desire is to support these new requirements, support the new stakeholders, and create more choice and diversity in the market. And I will attempt to change slides now. Let's see. There we go. So I want to talk a little bit about Project Cassini, even though Project Cassini is not directly tied to 5G, but we want to explain how ARM is helping the community. So Project Cassini is an umbrella project at ARM that captures various incentives that collectively provide standards, guidelines, and reference designs to help advance cloud native development in Edge, which includes 5G. So when we look at this picture here, starting on the left, you've got ARM System Ready certification, which brings firmware, drivers, and hardware together so that popular operating systems can just boot out of the box. So the idea here is to bring that experience that you're used to with x86 and Windows, where you can just receive a system, put in an operating system onto that system, and you should get all the drivers and the required firmware to just run that OS without patching. That's the key, and that's what we're doing with System Ready across the board on ARM products. On the other side of this picture, you've got Parsec. Parsec is an open source project that provides a standard interface for hardware root of trust access. So Parsec takes care of the intricacies presented by the various roots of trust and exposes a standard interface that is available in various coding languages. So you can envision building blocks where the back end of Parsec provides that specific connection to the root of trust. Parsec then has a service which gives you a set of functionality. And then on the front end of Parsec, you have the option of selecting the various front ends in different languages like Rust, Go, Java, that exposes a standard set of APIs to connect to the root of trust. And what I mean by root of trust, it's trust zone, it's TPM 2.0, HSMs, places where you can protect your keys and your secret in hardware. And by the way, Parsec is an open source project. It runs on x86 and ARM. So this is completely architecture agnostic. And finally, you see the ecosystem at the bottom here. So we work with the ecosystem to bring these tools to innovative, disruptive programs like Magma. And this is where Govind is going to jump in here and talk about what we're doing in the Magma project to help bring that solution on.
Thanks, Mark. About the enablement of Magma on ARM. Since last year, we have been involved in several architectural discussions with the Magma core team about how to enable multi-arch support in Magma. Multi-arch meaning making the Magma software agnostic to CPU architecture. The test cases and Magma CA are based on Vagrant and VirtualBox, and it doesn't work on ARM. We contemplated several options, and after several discussions, we concluded to take the path of containerization to enable multi-arch support. Once containerization is enabled, it is easy to deploy the AGW Docker image on any CPU-based system. Not only that, it will be easier to build Magma CI, which can support all the CPU architecture-based systems. We also had discussions about using a Kubernetes orchestrator to deploy containerized AGW image on Kubernetes worker nodes. Now, coming to the deployment of AGW, ARM and our partner Connect 5G ran AGW on several ARM systems, and we did an integration test with Bicel Radio and eNodeB software. And these are some of the ARM devices that's been used in the testing. It is AWS Graviton 2 instance and Hawkeye, Raspberry Pi, and even M1-based Mac. And we also built an ARM AGW AMI image, Amazon Machine Image, and it is based out of Magma 1.6 release, and it is available in AWS Marketplace. So these are some of the job that we have done so far. So what is next, right? Mark.
Just before we go to the next slide, but it sounds like there's a question. Is there a question from the audience? I saw a hand raised.
Mark, we can take the question towards the end.
Perfect.
We'll have enough time.
Yeah. On the next steps, ARM support will be enabled in upcoming Magma 1.8 release in June. We have run a sanity traffic test on AWS Graviton 2 instance, and we used SRS RAN traffic generator to run some basic UE attach test. With that, both the control plane and the data plane GTP traffic test passed. And then we would like to thank Meta team, Arun, Yusuf, and Praveen, and Magma community member Shubham for helping ARM to resolve several issues. So Magma users can now run AGW on any ARM systems with 5.4 kernel. Please come back to us if you face any issues. We can work together and resolve it. On the ARM CI front, Magma DevOps team is working on setting up ARM CI infrastructure with self-hosted runner support. Once self-hosted runner support is supported, ARM systems can be hooked up in ARM CI and you can validate Magma AGW features in it. So the containerized S1AP test are considered as the golden test in Magma. We will be working towards enabling those tests on ARM after 1.8 release. Next slide, Mark.
Thanks, Govind. Now, if you're wondering what systems are available, I know Govind talked a little bit about what was tested with Connect 5G. Govind will now go over some of these systems that are available and how they can be used for Magma.
Sure, thanks. Now coming to different types of AGW deployments. AGW can be deployed in a cloud, edge, near edge, and far edge locations. And we have ARM systems available from our partners to cater all these deployment scenarios. For cloud and edge deployments, you can use ARM-based AWS EC2 instance. It's called Graviton 2 and 3 and available in AWS region and outpost. You get up to 40% better price performance over comparable current generation x86 based instances. For near and far edge deployments, you have ARM systems from our partners like Nexcom and Hawkeye. You can also use Raspberry Pi if it suits your use case. Next slide, Mark. In this picture, Nexcom DTA 1376 system is used in near and far edge locations. A private 5G or LTE network can be created by running Magma core on this box to cater the client devices. This DTA box is connected to a remote radio unit to create a local breakout. Nexcom has support for different types of antennas for 5G and 4G and Wi-Fi modules. And it even has support for crypto offload to do crypto mining and different compute capabilities with A72 ARM cores in their boxes. Yeah, you can go check online for more details about the specifications and product offerings from Nexcom.
Thanks.
Next slide, Mark.
All right, we're going to talk about something really cool now. This is a system that was developed by AD-Link and it was released last month. So this is a Ampere developer workstation. It's a PC that is perfectly suited for 5G development at your desk or in your lab. So you can order this in different configurations. It comes in 32, 64, 80 cores options. The cores are Neoverse cores, so they're quite powerful. They're the same cores that you see in the popular cloud data centers. It has a bunch of PCIe slots, and this is where you can plug in these 5G acceleration cards to transform this developer workstation into a real 5G environment. This system is system ready certified or in the process of being system ready certified, and it's Ubuntu 20.04 certified, and it comes with Ubuntu preloaded. So check out the link below if you're interested. They're available on the AD-Link website for order. Again, this was released in April, just last month, and we're anticipating quite a bit of interest from the developer community, looking to develop on a powerful workstation at their desk. Now, here's a few 5G RAN acceleration cards that are based on ARM, and we're in the process of bringing these up in the Ampere workstation. Govind, can you tell us what you can do with these cards?
Yeah, thanks, Mark. As Mark said, this Ampere server has powerful compute capabilities. These Ampere cores are built based on ARM Neoverse IP. AWS Graviton 2 instance is also based on these powerful Neoverse cores. You can choose a server with 32 cores all the way till 80 cores. Now, what can you do with this powerful server with PCIe slots? Well, you can run both RAN stack and Magma core together to create a high-performing private LTE and 5G network. The ideal venue for this would be a stadium in which you can transport a live content using this server at low latency. This server loaded with all these acceleration cards can be carried in a truck to create a local breakout in a stadium and to do a live video streaming. You can choose to run the RAN stack completely in the CPU, or you have a wide variety of these acceleration cards from our partners like NVIDIA, Qualcomm, Marvell, and Genevisio to offload the distributed unit and centralized unit functionalities like PHY, MAC, RLC, and PDCP. If you can improve the performance of Magma user plane on par with RAN stack, you can achieve higher end-to-end performance.
Thanks, Govind. Now we'll talk a little bit about 5G solution labs, or we'll take a little bit of a step back here and look at what's happening in the radio access networks. Go ahead, Govind.
Yeah, so far we spoke about the mobile core part. As Kader mentioned, two eyes, right? One is the mobile core and other one is the RAN stack. So mobile core is the brain of the entire 5G or LTE network. The other complex piece in 5G network is the RAN. When you look at this traditional RAN, it is a monolithic piece of proprietary software running on a proprietary hardware. The RAN components are tightly coupled within the baseband unit. And thanks to Open RAN Alliance for forming different working groups to disintegrate this monolithic piece of RAN into RU, DU, and CU. ORAN Alliance created open interface specifications for these components to interwork. Now you can either run proprietary software on proprietary hardware and still comply with open interface specifications, or you can run this DU and CU portion of the software in a COT server in a virtualized or containerized environment. A lot of innovation is happening in this space and many new players are emerging. ARM wants to support these emerging players and embrace open standards. To facilitate it, we came up with ARM 5G Solutions Lab.
So together with Tech Mahindra, we created this 5G Solutions Lab. And the goal is to help tie together end-to-end networking infrastructure solutions with hardware and software ecosystem partners, and to demonstrate this to customers in a live test environment. That's the goal of this lab. And what we anticipate is that one day we will see the Magma core as one of the building blocks of the end-to-end solution. We're looking forward to that day where we can take that open source project and tie it into this end-to-end solution and demonstrate it to tier 1 telcos. All right, let's recap and look at how we can work together to continue to advance these developments.
Yeah, you can start using Magma on ARM. Mag is enabled on ARM. And you help us build the ARM CI. You can use the self-hosted ARM-based runners and run traffic tests to validate AGW on different ARM systems. And you can add new CI workflows to run containerized S1AP test, or you can integrate Magma with OpenAir interface and SRS RAN and do integration test and make it part of ARM CI. And we can also enable other Magma components like orchestrator and federation gateway and make it part of ARM CI. Yeah, please come and explore different ARM partner systems that we showcased here. There could be even more. You can reach out to Mark. He can share more information. In the ARM system, you can help us to create and bring the AGW orchestrator and cloud strapper AMIs to AWS Marketplace for ARM and use our partner solutions from Hawkeye and Nexcom for your near and far edge kind of deployments. And use the powerful developer workstation. You can integrate Magma Core with any ORAN software stack with or without those PCIe acceleration cards, and come up with high performance and more innovative solutions. And as Mark said, you can reach out to us if you have come up with a good solution, and we can help you to use our 5G solutions lab. You can join us on the Magma Slack. It is #ARM-support. And please join the weekly Magma ARM meeting as well, where we regularly share the ARM related updates. Thank you.
Thank you, Govind, Mark.
Thank you.
Awesome presentation. Couldn't wait to get hold of ARM hardwares and put softwares and make it work. Thank you so much for great input and great presentation. There are some follow-on questions. Let me quickly start with the question here. Govind, you mentioned about Nexcom. So the question is the Nexcom, the box that you showed in your presentation, does it have already the RAN stack available?
They are
available for production or just
so on the production front, Mark can answer. So they supply only the hardware. They don't provide the RAN stack. So you have to come up with your own RAN stack and run on it. So I think their product offerings are already available. I can see that online. So Mark, can you?
That's right. Yeah, the products are available. So Nexcom is an OEM or ODM, sorry, ODM. So they don't provide more than just the base software. If we want to create a solution with a RAN, we'd have to bring that ecosystem together in that box. And I'd be interested in exploring that. So it'd be something that we would love to partner on and work towards achieving.
Yeah, we are currently using this. I don't know whether you can see. This is the Hawkeye system. It has ARM cores in it, and we connect this to the bicell radio and do the LTE test.
Okay, nice. So it looks like you have a complete lab around you, Govind, there.
Yeah, I'm sitting in ARM office. We have a big lab here with all these devices. Yeah.
Nice. Talking about lab, the interesting thing is, you talked about your solution labs, and even at Wave Labs, we are putting up some labs working together with LFN. So these kind of initiatives will really help to have multiple people to, have a hands-on experience and enable the adoption of Magma in a bigger scale. Thanks a lot for that. The other question was, regarding this acceleration card that you kind of presented, has the Magma software been modified to sit in those accelerator cards to get the full benefit of accelerator cards, or is it,
So Kader, there are many developments that has to happen in Magma. So I'm talking in a very in future, Magma's future. I hope several 5G standalone features and non-standalone features will be added. Currently, it's all running in OVS kernel, right? If Magma community developers can, I'm just bringing out a possibility because you raised that question. You can move the OVS kernel to user space, and in that OVS user space and coupled with the DPDK, you have several options with SmartNICs from our partners like NVIDIA, Mellanox, and Broadcom Stingray. You can totally offload your GPU data plane traffic into those SmartNICs, and you can choose the ORAN stack of your choice. I don't know what is available in the open source, but there are a lot of private players, and anybody want to integrate the high performing Magma core with those RAN stack. Yeah, you can definitely use those RAN stack and try to offload a mix of capabilities. Like you can choose to offload just the PDCP portion or the MAC and 5 portion. So you can see some inline accelerator card. It does the complete layer 1 5 processing. It has the complex algorithms running in that, like the LDPC and polar encoding kind of algorithms. Those can be offloaded to that card. You can check the specification online. I may not be very accurate about the algorithms it supports. So a lot of tuning have to be done. And Magma community and Open RAN community, they can work together and try out these proof of concept, come up with more high performing, low latency solution, which is what the world is expecting.
Understood, Govind. Well said, really well said. I'm looking at some of the questions in the chat as well. So thanks to Kendall. She's kind of mentioned for those who attended today or not in the Slack channel, please, it's easy to remember, slack.magmacore, magmacore.org. If you just type in that, it will allow you to help you to join the Slack channel and work together with ARM, Wave Labs, and many other companies contributing in the community. And I also see some comments with respect to misspelling in the slide. Those are really good comments. That basically tells us you guys were really focusing on what we were saying.
What is it?
Misspelling in slides.
Is it?
maybe it's on WaveLab slides or
Okay.
Magma slides or some other. But that's okay, you know, as long as for me it's positive because it tells that they're really focusing on what we were presenting. Thanks a lot for that. Moving on, there was a question which talks about, is there a SOC option for RAN plus core?
What is a SOC option?
Yeah.
The socket level option. Are you talking about the S1 interface that connects the Magma core to the PDCP counterpart? Is that the question?
System on chip option, right?
SOC, system on chip. Okay. On which side? Is on the RAN side or on the Magma core side?
Maybe you can address core Magma, maybe core side, yeah.
So you have this, as Mark was showing, the AdLink based Ampere server. That's it has 64 ARM cores in it. I take the question as whether do we have any SoC with several accelerators for crypto and these L15s. I'm not sure about what are all the different possibilities or different acceleration components that are sitting inside an SoC. You can reach out to us. We can talk offline on that. I don't have a information ready.
Mark, I can just jump in for a second. Yeah. So the idea with this developer workstation is the flexibility that it provides. So these cards that you're plugging in is a development environment. When you're moving to production, what we envision is that AD-Link would get involved and they would optimize this box and they would drop all of these accelerators onto the main board, right? So that you get a system that's optimized and can be rolled into production at a much better price. So this is what we're focused on, is to give the tools to the developers, and then the optimization would take place during a production stage. So we anticipate that the development that you're looking for would happen in this type of developer workstation, flexible, plug in the cards, and then eventually optimize to bring that to a box.
And some of the acceleration cards that we showcased here, it has ARM cores within that with the accelerations in it. So it is available as different modules. What is I think Genevisio has a small cell entirely running as a PCI offload. I think that can cover all the entire wireless stack from PHY all the way till PDCP, I think. So you please go check. I may not be very accurate on the feature set.
Understood. Thank you, Mark and Govind. I'll probably take this question about the Magma in the LFN blueprint. So yeah, Magma is used as a core network in the LFN blueprint. There are number of open source and also the closed source vendors, and a vendor who adopted an open source and then delivering it as a commercial distro products. Or it's a combination of all these different things that makes up this end-to-end LFN blueprint. So in the lab right now, what we are trying to come up with is an architecture that can bring in some of the open source and closed source. Just to give you an example, radio from GenXCom Inc., Magma distro, then from orchestrator, lifecycle management, from Arna, and simulators from Rebecca, UPF from Kalun, and connectivity between multiple lab locations, transport SDN from Ternium. So I'm just giving some of these examples, or basically come together to make up this blueprint where Magma is part of it. It's very important, like I mentioned, not only having an expertise is good enough to enable the adoption of Magma, but we have to create an ecosystem around Magma. That is the key to the success of adoption of Magma for 5G or even for 4G, right? There's a couple of questions on the MyCloud BSS. So I'm not sure if Bhavin is in the call or Parthiban, are you in the call? So the question is, the demo that was showed is more or less, onboarding the subscribers and, assigning them to the package and running it and showing it how it is getting detected in Magma and getting reflected in BSS and so on. But it was not showing, the demo was not showing anything on the subscriber-based modules. So do you have a subscriber-based module supported where subscribers can log into the app or backend to, top up, top down and things like that? That's the question. Bhavin,
yeah, Bhavin is also available, Kadar. This is Parthiban here. So if you take a close look at the demo, what I showed at the end of the demo, once the SIM gets added, the subscriber gets added, the data plan is assigned, then the end user has an app as well. And you could be able to go into the end user app. You can view what was the data plan purchased by that end user. The 1 GB was shown in the demo. So end user will get notifications about the consumption of the data as well. That's where at the end of the demo, you could see that it was reduced from 1 GB into 0.9 and 0.8 GB of the data consumption when the traffic was flowing into the user. So there are available web app, SaaS-based app, as well as mobile app on Android and iOS as well, available for end user to upgrade the data plan, downgrade the data plan, raise a query into the service provider, do a lot more stuff than what required. It's all available.
Got it. Perfect. Nice answers. And there was another question: do we have a real production deployment? Yes, I can answer that because we are an exclusive reseller of that. So it's been deployed in 2 FWA vendors, and there's a couple of vendors using that to create a end-to-end network as a service offering for FWA and private wireless. So yes, it has been production deployed. Even though it's a nimble product, it has lots of features that could be very useful for end-to-end integration, very cost effective. So almost we are close to the end of the session, 1 minute over time. If there is any last question, I don't see anything in the chat. So with that, what I would like to do is I would like to thank Mark and Govind for their wonderful presentation. I sincerely encourage every one of you to get into their Slack channel, in ARM Slack channel in Magma Slack, and learn more, and also their meetings that they have. Please join and learn more. There's a lot of possibilities to make Magma work in a more accelerated way. And also I would like to thank MyCloud BSS, Bhavin, Parthiban for all the efforts put in to integrate with Magma, in addition to all the other cores that they have already integrated. Thanks again for showing that presentation, taking time to prepare demo and share it. Thanks again to some of the TSC members, community members, and everyone for joining and continuing to contribute towards the success of adoption of Magma. So with that, I'd like to wish you all a wonderful rest of the day and happy weekend. See you guys in next monthly Magma meeting in 4 weeks from now. Mark, any final words? Please go ahead before we close it.
Just thank you very much for giving us the opportunity to speak today. And we hope to see you all in the community chats.
Yes, please. Yeah, please join the meeting as well every week.
Sure.
We need more hands.
Sure. Yeah, you can count on me. At least I'll send some of our guys to your meeting for sure. Yeah. Thank you very much, guys. Have a wonderful day. Bye-bye.
Bye. Thank you all.
Thank you all.